Welcome to all. Welcome for today's session. Today we'll be having an introductory session about cloud computing. So before starting up the session, let's have a small introduction about myself. So my name is Rishabh. I've been into IT from last 7 years. From last 4 years, I've been dedicatedly working on the cloud platforms involving various clouds like Google, Amazon, and Azure. In my cloud journey, I have worked with top MNCs and worked with different clients and helped them to deploy their applications on the cloud platform. So we have migrated the applications from an on-premise system to an cloud infrastructure. We have developed the applications over to the cloud infrastructure as well. So in today's session, we'll be seeing what is cloud computing and how does the cloud computing became so important in our current IT scenarios. So starting with, if we talk about cloud, so if we say in a very layman language what a cloud is, or why do we need a cloud platform, or what are the benefits of using the cloud, so anything that comes to your mind? If I say in basic terms, we all know that cloud can be a remote storage, a remote machine that we can access, or a place where we can have our data and everything stored. So when we talk about cloud, it's just that we are reducing the dependencies on physical infrastructure. Let's say a very basic example that we have our smartphones and we have Google Drives or OneDrive synced with our smartphones. The whole sole reason behind syncing our drives with our smartphone and having our data uploaded over those drives is, if tomorrow if I lost my phone or if I'm not able to access my data over the phone, I can still have that data with me and my data is not lost, or I do not have to go with that circumstances where I'm not able to access my data. So as my data is now uploaded to these drives, even without having my phone, I can log into these drive with some another mechanism and access my data. Correct? So that's the basic thing then when we talk about cloud. So that we are reducing the dependence on a physical device. That means with cloud, we are no longer dependent on a physical storage or a physical server for our operations. Let's take another example. You all might have heard about Microsoft Office and maybe have worked upon it. Correct? So earlier, if we want to use a Microsoft Office, what we need to have a system, we need to purchase the license and then install Microsoft Office on our machine. Now if I produce a document using Microsoft Office and I want to present it to someone, then either I need to take my machine with me, or I need a machine where there is Microsoft Office pre-installed, because I can open those files, either a Word file or a Excel sheet, only to the same software platform. That means again I was dependent on my physical device. But let's say with the coming up of the Google Cloud, or with the Google Cloud launching the feature of Google Docs, Google Sheets or Google Slides, now I can easily create my Word documents, Excel sheets or PowerPoint over the cloud platform without even spending a single penny, because these I don't need to buy a license anymore. I don't need to have a system anymore. Plus, if I want to share that document with anybody else, I can easily share and present it with a system that just have an internet connectivity to it. That means with the help of the cloud, our lives are becoming easy, our involvement with the applications are becoming easy, and we can do any task anywhere without depending on the physical infrastructure or physical devices that we have. So this is a cloud in a nutshell. So let's see what was the disadvantage, or why do we need a cloud, or how did cloud came into an existence. So if we talk about our previous architecture that we used to have, we all know that we were working on a simple client-server architecture, where we had a client and our client used to send a request to the server and server used to get the response back to the client. But what was actually wrong with this architecture, or what was the drawback of this architecture? Let's discuss that in detail. So We will discuss it with the help of a small example where we have a client, and we have this client is sending a request to the application, and then application is responding back to this client. So to talk about in detail, let's switch to a diagram. So let's say we have a client that is sending a request to an application or a server, and this server is sending back a response. So first let's quickly talk about this client. This client could be in any device. It could be your laptop, your mobile, or a tablet, and it would have a basic hardware configurations like your 8 GB RAM, 1 TB hard drive, and 4 CPUs. Similarly, over the top of this hardware we have an operating system like our Windows, Mac, or Linux, and over those operating system we have different applications running, your Chrome, your browsers, your notepad, your any kind of an application that you use in a daily environment. Now let's say using one of the application Chrome, I send a request to a server. Now these servers are not the regular server. These are the Xenon servers, which are huge in capacity. Let's say 500 GB RAM, 1000 TB of hard drive, and 800 CPUs. That means these servers are capable of having the load of multiple applications together. Now over these servers again we have an operating system, mostly Linux because of the security concerns, and over that we have multiple applications. So in this we have 6 applications. Let's say application A is my application, that is CloudImmer. Now this application is a general application and it uses 2 CPUs, 1 GB RAM, and 500 MB of storage, just a small application. Now let's say somebody attacked on my application, like a DOS attack. So everybody knows that in a DOS attack the application receives so many requests that it's not able to fulfill all those requests. Plus when the incoming request increases, application will need more and more resources to process that request. In ideal scenarios it has used only 2 CPUs, 1 GB RAM, but now as the load on this application is increasing, what will it do? It start taking the resources from its neighboring applications. That means it will start utilizing the RAM and the CPU of application B, then C, then D and E, and even the resources that are consumed in the free pool. That means all those resources that not even utilized by these applications will again be utilized by a single application, that is application A or my application CloudImmer. So now even after the utilization of the entire resource, there would be a time where this server CPU and RAM would be 100% utilized. That means now there will be no free storage, no free memory for this application to consume. And as with the CPU utilization being 100%, what will happen? This server will crash, or this application will crash. As soon as this application will crash, will also lead to the crash of the entire server. That means all the entire applications that are deployed on this server will also crash. You can imagine this scenario is similar to your regular, like you are using an application, let's say Windows Media Player or VLC Media Player, and parallelly you are using a browser. Let's say your media player got hanged or it start consuming resources. So what will it do? It will make your system slow, and a time will come when the CPU and RAM of your system will be highly utilized, because a single application, that is the media player, is utilizing those resources to the full. Now what will happen? You need to restart your machine or you need to shut down your machine, leading to the crash of the server. Similarly, in this scenario we have different applications. Because of one application getting overutilizing the resources, the entire application goes down. So this was the problem or the drawback that we used to have in a scenario of our client-server architecture, correct? So now to overcome with this scenario, we came up with some concepts, with some things that help us to prevent this scenario, prevent these things from happening. And what was that? It was all because of the virtualization. Now what do you mean by virtualization? Let's say I have a host machine, correct? And I have Windows on my host machine, and this is the basic configuration of my host machine, 8 GB RAM, 1 TB hard drive and 4 CPUs. Now I want to run a parallel OS, let's say Linux, on over the top of my Windows. So one option I have is I can format my laptop or my machine and install the other OS. Or what I can do, I can create a virtualization or a virtual environment for my application and then install this secondary OS over it. So you must have heard the tool about VMware. It's a very famous tool that we use to create virtual machines. So what we do with the help of this VMware, we add a virtual environment or we add a virtual layer to our over the top of our Windows. Now inside that Windows or inside this virtual environment, I can create a secondary OS or I can install a secondary OS. Now this OS will also use some hardware. Out of my total hardware out of my host hardware, I can assign some amount of hardware to this virtual machine or virtual OS. Let's say I assign 4 GB RAM, 500 GB hard drive and 2 CPUs. Now with the help of this hardware, I can now run this OS. Plus this OS is running inside my virtual environment. So now tomorrow if there is some issue with this particular OS or the I am facing some virus or some attack over this OS, this will only affect this particular machine or this particular OS. My rest of the machines will not be affected because this is a virtual environment, and then you can consider it as a two separate machines running on a similar hardware. Plus I can also create another OS by again utilizing the same resources. So now I have two benefits of using the virtual machine. First, using the single hardware, that is 8 GB RAM, 1 TB hard drive and 4 CPUs, I am able to run 3 different OSs. Correct? It would have been a separate scenario. I would have to buy 3 different sets of this hardware for these 3 different OSs. Plus I can share the resources. Plus if there is some issue with these of the two OSs, if any one of the OSs face any issues, some viruses or some attack, it's not affecting the another one or the host machine. So that's the beauty of the VMware or the virtualization. Now this virtualization can be achieved with the concept known as a hypervisor. So VMware is also a kind of a hypervisor. We have hardware hypervisors and we have software hypervisors. So coming back to our demo, so now client-server architect would look similar to this. So we have a physical hardware. Over that physical hardware, we have a layer of hypervisors. And now using this hypervisor, I can create different virtual machines. That means I can have a virtual machine A, virtual machine B and virtual machine C. Each of these virtual machines are using the same hardware, but they can have their own OS and their own application. Now if there is an issue with one particular OS or one particular application, only this particular application will go down, or this particular application will only be affected, not the other two applications. That means if this application goes down, only this goes down, not the entire server or nor its neighboring application. So that's the beauty of cloud, that just a single piece of hardware I can run multiple OSs. Plus if there is an issue with one of the OS or one of the application, it's not affecting my other applications or other systems. And how is it possible? Because of the hypervisor. Now these things have already been developed. Now when we'll be learning cloud computing, we will be seeing that how the services that have been developed or how the systems that have been created using these concepts is useful to us, or how can we save the cost to our client, because we know cost saving is the topmost priority. Plus how can we make the task easy, as I don't have to dependent on my physical hardware, do not need to pay overprice for my resources. Plus I don't want to maintain and monitor different things. I want to make my life easy so that I can work more efficiently. So all these tasks can be done with the help of the cloud. Moving ahead, we'll see why should we choose cloud as a career option. So if we talk about the different languages that we know or different technologies that you are aware, like software testing, development, so all these languages are old. You can say 20 years, 15 years. When Java was developed, Python was developed, .NET was developed. But how many of you have heard the word cloud more than 8 years back? So cloud being a recent technology, and we know that everybody, every application wants, or every client wants to move their cloud, because it's easy, it's fast to deploy, it's secure, and it's easy to manage, and plus most often it's cost optimized or cost efficient. And as we can see through this graph, as per this year 2020 or 2019, last year, we have only utilized 11.3% of the total market potential. That means out of the total market potential, only 11% or 13% market is on cloud. And we know with the ease of this technology, a lot more people will try to migrate on cloud, will try to move on cloud, and then we would be needing cloud professionals, cloud engineers, who have the ability and who have the potential to work on these cloud platforms. So during this course, we'll be seeing how can we make this application, or how can we move different applications on cloud, how can we make the use of different services that are provided by cloud, and how can we grasp this opportunity to be a market leader. So in this entire course, we will be talking about this thing only, and we'll be seeking and we'll be learning this knowledge only, that how to grow on cloud. If I talk about, there are different platforms. We have Azure, we have Google, we have Amazon. But why do we need to go with AWS only? Why not I should learn Azure and Google when we have? Because as per the scenario, AWS itself covers more than 90% of the total market. Rest of the market is shared by Azure and Google. And the reason being that AWS covered so much potential is the ease of the use, their usability, their pricing, their services that have been provided by AWS is much and much more as compared to Azure and Google. Google is still on the experimental usage. Azure is basically provides most of the Microsoft prototypes or Microsoft products. But Amazon provides end-to-end services and end-to-end products, from varying from, you name any technology, you'll find the products from machine learning, you'll find from data analysis, normal compute, storage, databases, anything. So a wide range of opportunities you have. Be you be a network engineer, be you a software developer, or be you be a database admin or a system administrator. Cloud or Amazon has the potential for every domain, correct? Plus Amazon is easy to learn. The complexity is not that much as when we talk about Azure or Google. And you name any top brands, Airbnb, Netflix, your Apple Cloud. Apple Cloud is also using a major part of Amazon Web Services. So learning Amazon Web Services is the right and the best opportunity for you to grow as a cloud professional, to grow as a leader, and to have a good career opportunity in the market. So guys, if you have any questions, if you have any doubt, feel free to connect with us. We have our details. If you have any doubts, any queries related to the course, related to the content, we are there for you. You can mail us to contact@technogeeks.co.in, or you can connect us on these numbers. We will be happy to help you. Thank you guys.